not just about numbers, equations, computation, and solving problems. It is also about understanding. Hello, Jacobians! My name is Michaela, and these are my primates, Elnie, Adeline, and Janice. The lesson we're going to discuss is about mathematics of graph. First, we introduce what graph means, how to construct a graph, the equivalent of graphs, film tracing puzzle, and the graph coloring. Mika, Janice, Elnie, what comes to your mind when you hear or say the word graph? Do you have any idea about it?
We are here to give you some point of view of our lesson, which is about mathematics of graph.
Let's start! A graph is a set of points called vertices, and line segments or curves called edges that connected vertices. A graph is a finite set of dots and connecting links. The dots are called vertices or nodes, and the links are called edges. A graph can be simplified a real-life model, and this is the basic structure of graph theory. What is graph theory? Graph theory deals with the relationship between objects. Objects are presented by dots or points, which are technically called vertices. Objects are related if there is an edge represented by line, segment, or curves that connects them. A vertex or node is a dot in the graph where edges met. A vertex could represent an intersection of streets, a landmass, or a general location like work or school. Note that vertices only occur when a dot is explicitly placed, not whenever two edges cross. Imagine a freeway overpass. The freeway and side street cross, but it is not possible to change from the side street to the freeway at the point. So there is no intersection and no vertex would be present. Normally, capital letters are used. Edges. Edges connect pairs of vertices. An edge can represent a physical connection between locations, like a street, or simply a route connecting the two locations, like an airline flight. Edges are normally labeled with lowercase letters.
Weights. Depending upon the problem being solved, sometimes weights are assigned to the edges. The weights could represent the distance between two locations, the travel time, or the travel cost. It is important to note that the distance between vertices in the graph does not necessarily correspond to the weight of an edge.
Looking at the graph here, we notice how edge AF and edge CD have the same length, but their weights are different. So graphs don't have to be drawn to scale. It is important to pay attention to the weights of the edges when they are given.
Loop. A loop is a special type of edge that connects a vertex to itself. Loops are not used much in street network graphs.
Looking at this graph here, this would be the loop from this vertex.
Degree of a vertex. A degree or balance of a vertex is the number of edges meeting at the vertex. It is possible for a vertex to have a degree of 0 or larger.
So these are the several examples. Here's the vertex with degree of 0, degree 1, degree 2, degree 3, degree 4.
Path. Path is a sequence of vertices using the edge. Usually, we are interested in a path between two vertices. For examples, consider a path from vertex A to vertex E.
The example of path from vertex A to vertex B to vertex C to vertex E, and it can be also from vertex A to vertex B and vertex E.
Circuit. Circuit is a path that begins and ends at the same vertex.
The example of circuit is starting in vertex A to vertex B to C, D, E, and back to A. There's another circuit from A to B, E, F, and back to A.
Connected. A graph is connected if there is a path from any vertex to any other vertex. Every graph drawn so far has been connected. A graph on the bottom is disconnected. There is no way to get from the vertices on the left to the other vertices on the right.
Our topic is all about a graph. A graph can include vertices that are not lead to my edge, but all edges must begin and end at the vertex. If two or more edges connect to the same vertex, they are called multiple edges. If an edge begin and an end edge at the same vertex is called a lump. A graph is also called connected of any vertex. Can be extended from any other vertex by tracing a long graph in which every possible edges is down between vertices is called a complete graph. Several examples of the graph that shows below. In the first picture, first, this graph that vertex but the edges is not connected because it's separated each to each other. Second, this is a connected graph because that has a scale of multiple edges when two edges cross in the center but there is no vertex there. Unless a dot and down, the edges are connected to each other without touching. Third, this is a graph that is not connected because it contains of different direction and it is also contain a loop that consists of any collide each other. And the last one, the fourth, this is a complete graph because with 5 vertices, it's connected to each other.
This video will explain and cite an example in constructing a graph. So the following table lists 5 students at a college. 5 students named Matt, Uber, Oscar, Laura, and Kyla. An X indicated that these 2 students participate in the same study group this semester. So A, draw a graph that represents this information where each vertex represents a student and an edge connects 2 vertices if the corresponding students study together. So we draw 5 vertices in any configuration we wish to represent the 5 students and connect vertices with edges according to the table. So B, use your graph to answer the following questions. Which student is involved in the most study group with others? The vertex corresponding to Amber is connected to more edges than the others, so she is involved in more study groups than the others. Which student has only one study group in common with others? Kyla is the only student with one study group in common, as you can see, as her vertex is the only one connected to just one edge. How many study groups does Laura have in common with the others? Laura's vertex is connected to 2 edges, so she shares 2 study groups with the others.
Hello everyone, my name is Lisa Javerichano Apundar from the tribe Jacobian. Check your progress. The table below lists 5 mobile phones companies and indicates whether they have agreements to roam onto each other network. Draw a graph that represents this information where each vertex represents a phone company and an edge connection vertex if the responding companies have a roaming agreement. Then use a graph to answer question. Which phone company has roaming agreements with the most carriers? Which company can roam with only one other network?
Good day everyone, my name is Mary Espen Salamanque Mary From Section J, I'll be discussing about equivalent graphs and their definition itself.
Equivalent graphs. It has two non-isomorphic graphs are said to be chromatically equivalent, also termed chromatically equivalent by Barry 1974. If they have identical chromatic polynomials, a graph does not share a chromatic polynomial with any other non-isomorphic graph is said to be a chromatically unique graph. It illustrated a simple graph. We can determine if it is equal and it's shown 5 or fewer vertices.
Let me define the word equivalent.
Equivalent means belonging to the same equivalence class. In additional, equivalent expressions are expressions that work the same even though they look different. If two algebraic expressions are equivalent, then the two expressions have the same value when we plug in the same values for the variables. Example problem of equivalent. The problem is 5 times x minus 1 plus 7. So, first thing to do is copy the corresponding number, which is 5, then times it by x, plus copy again the corresponding number, which is 5, then copy the negative 1 and times it, then copy the last number, which is 7. Second step is 5 times x is equal to 5x, then 5 times negative 1 is equal to negative 5, then bring down 7. So bring down 5x, then negative 5 plus 7 is equal to positive 2. The answer is 5x plus 2. Graph is a diagram showing the relation between variable quantities, typically of the two variables, each measured along one of a pair of axes at right angles. The object corresponds to mathematical abstractions called vertices, and each of the related pairs of vertices is called an edge. Example of a graph. Multigraphs may have multiple edges connecting the same two vertices. An edge that connects a vertex to itself is called a lobe.
I hope you understand what I've discussed. Thank you and good day.
Good day everyone, I am Rosario from Ala from BSE 1J, and I am going to discuss the edges of the graph. A complete graph has an edge between any two vertices. You can get an edge by picking any two vertices. So if there are n vertices, there are n choose 2 equals n2 equals n multiplied by n minus 1 divided by 2 edges. This means that every vertex is connected with every other vertex. If you take one vertex of your graph, you therefore have n$ minus $1 outgoing edges from that particular vertex.
Good day everyone, I am Shinamay Karingal Mora, and I am here to discuss and give an example of equivalent graphs. I show you the example of the equivalent graphs. If I have a set of vertices with A, B, C, and D, and I connect them with the edge of here, here, and here, then graph is actually the same if I just did this. We gonna call this with D, A, B, and C, and I gonna connect them from here, here, and here. Two graphs are equivalent when they got the same number of vertices and the same edges between the same specific vertices. Here, I get the edges between A and D, between A and D, A and B, and between A and B, and the edges between B and C, between B and C. So, some number of vertices and some number of edges, and the edges go between the sum number of vertices. some graphs that won't necessarily look alike screen like the same thing. And I'll show you an example. I show you the example 1. With of A, B, C, and D. And also I show you this one. With A, B, C, and D. I connect the one example with the edge of here, here, and here. Also here, and here, and here. So you can see that these two graphs is very different. So I have to connect between the edges of A and B, A and B. Also between A and C, the A and D, between the B and C, B and D, and also between the D and C. So I got all the edges, and this both is equivalent graph because these two have the same number of edges and the same number of vertices, and those vertices are connected with the same edges. So this is a very different graph, but in the end of the day, it doesn't matter how we draw the graph. The important is they have the same number of edges and the vertices. So that's all, and I hope you will understand my explanation about the equivalent graph. Thank you, everyone.
Now, we will discuss about pen tracing puzzle. So, what is pen tracing puzzle? Pen tracing puzzle is a computer version of the classic pencil and paper puzzles in which the objective is to trace the diagram without taking the pencil off the paper and without going over the same line twice. In order for you to understand more about this topic, here's the example of how to do the pen tracing puzzle.
Hi everyone, I'm going to show to you one of the example of pen tracing puzzle. Tagalogin ko na lang po yung pag-explain ng example for you to be able to understand well the pen tracing puzzle.
Yung pen tracing puzzle po is without lifting a pen and without holding a paper. Kumbaga po, yung pen tracing puzzle is dire-diretso lang.
Can you draw this without lifting the pen and without tracing the same line more than once?
As you can see, I started at one vertex and ended at the same vertex. Since the graph is connected and every vertex has an even number of segments joined to it, you can start at any vertex and end there, covering all the segments. Another example. Start on the red dot and move your pen once. It is possible and it's actually quite easy.
Hi everyone! I'm going to show you another example of a pen tracing puzzle. From the definition itself, we are going to trace a diagram without lifting up a pen. So, here it goes. So, that is an example of a pen tracing puzzle.
Now, we will discuss about graph coloring. Graph coloring started in the mid-1800s. Graph coloring is another aspect of graph labeling. Francis Guthrie tried to color the map of England so that it would be easy to distinguish the countries sharing a common border. Countries with the same border must have different color. So, ang mga bansa na may parehong hangganan ay dapat magkaroon ng magkakaibang kulay, like for example, Libya, Egypt, Chad, and Sudan. As you can see in the picture, so they are the same border, but meron silang itinakdang kulay para hindi magulong tingnan. In graph coloring, each vertex of a graph will be assigned one color. No two adjacent vertices have the same color. A practical application of graph coloring problem is in scheduling meetings or events, and as you notice, na-try na ito sa mapa. Graph coloring is nothing but a simple way of labeling graph components such as vertices, edges, and regions under some constraints or limitations. Planar graph. A planar graph is a graph that can be drawn so that no edges intersect each other except at vertices. As you can see in letter A, bawat vertices connected pero hindi siya naulit o hindi nagtama yung mga edges nila sa bawat isa. And magkoconnect lang siya sa mga vertices ng edges, yun ang planar. In letter B, pwede siyang ito connect dito, dito o dito. Yun ang non-planar, pero dito sa planar, dito sa mga edges at vertices lang.
The topic I discuss is about chromatic number. Chromatic number is the minimum number of colors needed to color a graph so that no edge connects vertices of the same color. So, it means ang chromatic number ay ang pinakamababang bilang ng mga kulay na kinakailangan upang kulayan ang mga vertex na walang katabing mga vertex na nagbabahagi ng parehong mga kulay. So, next is two-colorable graph theorem. It is a graph is two-colorable if and only if it has no circuits that of an odd number vertices. So, a graph is two-colorable if we can color each of its vertices with one of two colors, let's say red and blue, in such a way that no two red vertices are connected by an edge, and no two blue vertices are connected also by an edge. Another thing to know if a graph is two-colorable, do a red first search, assigning red to the first layer, blue to the second layer, red to the third layer, and etc. Four-color theorem. It is the chromatic number of a planar graph is at most 4. So it means every planar graph can be four-colored. Take a look of this photo. This is the example of four-color theorem or four-color map theorem. I'll give you the example 1. Consider the complete graphs K4 and K5. Determine their chromatic number. So these two picture is referring a proper vertex coloring of the Peterson graph with 3 colors, which is the minimum number is possible.
Example 2. North Central is offering 8 courses during its summer session. The table shows with an X which pair of courses have one or more students enrolled in common. Only 2 air-conditioned lecture halls are available for use at any one time. So to design an efficient way to schedule the final examination, represent the information in this table by using a graph. In the graph, represent courses by vertices and join 2 courses by an edge if there is any students enrolled in both courses. Keep in mind that the graph telling us 2 vertices were connected by an edge cannot be scheduled to have their exams. Note the
same time because the edge represents student that it is enrolled in both courses. So now we're simply do a graph coloring. So pick a vertex to start. How about the French? Assign a color to a blue. Next is math, assigned as orange because it is not connected to French. I mean, it is connected to French. Next is English. So it is connected to math and French. English, so it is not, or should I say, English is connected to math and French. So it cannot be orange and blue. So I assigned it a color violet. Next is Italian. So it cannot be blue, orange, and violet. So it can be green. Next is history. It cannot be green, so it can be blue. Next is Spanish. It cannot be green and blue, so that it can be violet. Next is philosophy. It cannot be blue, but it can be green. So the last is chemistry. So it cannot be green, blue, because they are connected. So it can be orange. So that's all. Thank you.
Example number 2. North Central is offering courses during its summer season. The table shows with an X which pairs of courses have one or more students in common. Only 2 air-conditioned lecture halls are available for use at any one time. These are the table. To design an efficient way to schedule the final examination, represent information in this table by using a graph. In the graph, represents courses by vertices and join 2 courses by an edge if there is any student enrolled in both courses. Figure 1 shows the graph by making a vertex or vertices for each course listed. Figure number 2 shows that how to connect the edges from French to chemistry. For French, we need to add an edge from math. Figure number 2 shows that how to connect the edges from French to chemistry. For French, we need to add an edge from math, philosophy, English, Italian, and chemistry. For math, we need to connect it from French, English, and Italian. For history, connect it to Italian, Spanish, including chemistry. For philosophy, connect it to French and Spanish. English, connect an edge to French, math, and Italian. For Italian, connect an edge to French, math, history, English, and Spanish. For Spanish, add an edge to history. Lastly, chemistry. Connect an edge to French, history, philosophy, and Italian.
Mathematics is numbers, equations, computation, or problems. It is about understanding.